Hello and welcome to another advanced deep dive. So this time around we're taking a look at one of my favorite topics, artificial intelligence, and we're using one of my favorite methods, goal-oriented action planning, or GOAP. So this is a method that's been used in a lot of games. I'm personally a big fan of this method. It's my kind of go-to method for stuff because I find it a lot easier to plan out what the behaviors are going to be to get them up and running. So I find it's more flexible than state machines and gives a bit more of an organic sort of reaction there, but it's less setup overhead compared to behavior trees. And I find it's also easier for debugging it. So we're going to be taking a look at it. Now, for a bit of an overview, there are a couple of different ways of doing GOAP. And in this video, I'm going to be focusing on what's called a more monolithic approach to it. I will do another video looking at the microlithic or fine-grained approach to it, but for this approach, we're going to be looking at a sort of more monolithic setup. So how it works is we have different goals. Those goals have different priorities. For example, we might have an idle goal that has a really low priority. It's there as sort of a fallback. But then we might also have a goal that is a really high priority one, like fleeing, but is most of the time turned off until we take damage. So which goal is active at any point in time is down to its priority and also just a general thing of whether it's saying, actually, can I run under these circumstances? So it means that we can have those priorities changing and shifting. So if a character has a goal for obtaining some resource that they need, that priority can change based upon how desperate that need is. So as the need grows, then that priority can change until that goal then just naturally becomes active and becomes the priority thing to do. So goals are the first point. Goals are working out what we're trying to achieve. Then we have actions, which actions are the process of how we achieve a goal. So with the more monolithic approach, actions are fairly large in size. One action can entirely complete a goal. And you might have multiple different actions that can complete it. They can have different costs, but one single action is able to complete a goal. The more microlithic or fine-grained approach, what you do is you assemble a chain of actions to achieve a goal. So you're using actions more like little Lego blocks and trying to assemble them together to get the particular result. So I prefer the more monolithic approach. I find that it's easier for planning and you can really sort of reuse a lot of stuff between the actions anyway. So that's what we're going to be taking a look at. So let's take a look at the setup that we've got. So I've combined a few things from previous projects. And so we have our enemy character here, which our enemy character has the awareness system that I built in another video so that they're able to be aware of different things that are around. And they also have the ability to move. So I've given them the navigation side of things there from other previous stuff as well. So what we're going to be able to be doing is we want this to then have our goals and actions on it. So we're going to collapse all of this and what we're going to do to start off with is we're just going to build the goals. So we're going to build the goals. We want to see those priorities changing and shifting over time. Then once we've got those goals working, then we want to start building our planner that's going to work out, well, which goal is active, and then trying to find an action that matches it, and then finally we'll set up the actions. Now with this, one of the hard things can be getting a bit of a sense of, well, what code goes where. So we'll talk through that as we go through sort of the process here. So goals, well, we want to have some common information there with the goals. So one of the things I'm going to do is make use of inheritance here. So I'm going to set up a base goals script, and that's going to have common elements there because we know there is going to be a lot of commonality with the goals. So we'll have our base goal. I want to create a couple of other ones. So we're also going to have a chase goal. So for the AI character being able to pursue us. We are going to have an idle goal. And then finally, we will have a wander goal. So the intent here is I want to have enough goals that I can illustrate a few different ways of working with priority. So some ones where the priority is fixed, some ones where that priority is a sliding scale, and other ones where it's kind of a little bit of a combination of both. Key thing is we always want there to be stuff that the character is able to be doing. So our base goal is our starting point. So our other goals will inherit from this, and this is going to be the key starting point. So our goals are going to need a couple of things. Well, for one thing, the goals are what talks to the character for telling it to move. So that means if we take a look at our character agent has methods here for being able to move to locations. So one of the things the goal is going to need is it is going to need a link to the character so that it can actually tell it how to move. So we usually do this split that the behaviors don't directly perform the movement. They will usually talk to something else, often called the navigation system, to perform that movement. So in this case, we want to have that link there. So we'll have that, and we want this to be protected because this is going to be something that the other goals are able to access. So it's child goals. So we want to have our agent. Now we also have our awareness system. So we have from our sensors. So in this case, what we want to do is we want to talk directly to that awareness system there. So protected awareness system. And I'm just going to call that sensors. So again, that's something we need to talk to so that we can find out information about the world. So what we will be doing is in start, we'll retrieve all of these. And that will, because they're all in the same object, makes it nice and easy. So the sensors will retrieve that. And I will actually put this in awake so that we're doing this very early on. So, okay, we'll have our setup there in awake. And what I want to do is I don't want the child classes to implement anything in start and update. I don't want them actually working with that. So what I'm going to do, and also these goals, we don't want them to just tick on their own necessarily. But what I want to do is be able to sort of control what's happening, the timing of when things happen. So I'll have it end up having a commons GOAP script that controls how the goals get activated, how the actions get activated typically. So start, I am going to set up some functions here. So protected virtual pick goal. This just gives us something that the child classes can override this instead. And we'll have void on calculate priority, which that will return the priority. And I might make the priority an integer. So we'll go from 0 to 100, which what I'll do is intentionally, in this case, I will return thing. We've got ability to calculate the priority. We can tick the goal. We want to know when a goal becomes active or not. So we're going to have a couple of other ones here. Virtual void on goal. And then virtual void on goal deactivated. Now, in most cases, we won't need to be doing anything in these, but it just gives us some hooks here for if we are having to kick off some logic when we start a goal or stop a goal, because goals will be able to get interrupted. So we want to be able to kick off logic here if need be. And the final thing we need really with this is whether or not it's able to run. So can run, which will default to returning false. And that one's, there we go. So we've got our key interfaces, the key things any goal needs to be able to do. It has to be able to calculate priority, has to be able to tell us whether or not it can run, has to be able to be ticked, activated, deactivated. Now this is something where I could also set these up as an interface. So I could create a interface here that is for goals that defines that these things have to be present. And that's something that we might look at as a later modification, because the key thing with interfaces is we can't set a return value. So interfaces, we don't have any implementation there. The other thing with interfaces is you can't define something as being private or protected. It has to be public with an interface. But this gives us our initial setup here. And actually, those do need to be public. So let's go for having an interface. So interfaces, general convention is things start with I. And we can bring all of our ones up here. Protected all becomes public. So interfaces, everything must be public, like this. Actually, we don't even need to specify public, which I'll remove in a moment because it defaults to public. So we can get rid of that. And then end of those. So we could then say this implements iGoal. Now this will get grumpy at us because we have to make these public. But that's another way that we can set this up, of just defining the key things there. So we've got our base goal here. Well, let's take a look at then getting some of these other ones set up, because we want to have our different goals. So we'll have our idle goal first, is a good one. So this inherits from goal base. So idle is a really simple one. Idle, we know we need to implement these functions. So calculate priority, we're going to make it that we can actually just configure a default priority for it. And it's just going to always return that. And idle can always run. So our goals tend to be quite simple in terms of the logic for them. They don't tend to do particularly large amount. So this is all that would be there for the idle one, because it's a fixed priority. It's there as a fallback. It's there if there's nothing else more important for it to be doing. So it can always run, and it has a fairly low priority, but one that we can configure in the inspector so that we could, for different characters, have different priorities. So, okay, that's good. What about if we look at the setup then for something like our wander goal? So again, we get rid of our start and update and everything there. We have our goal base. So I'm going to grab the functions again from idle. We'll use those as our starting point. So the criteria we want for wander. Wander is again a fallback thing, but we want it to be a case that it only decides to wander if it's been stationary for a length of time. So I want to have a couple of things in terms of, okay, a min priority for wander. So this is just a baseline priority that it will always have, which is actually going to be 0. And then we'll have a max priority, which might be 20. So don't want it too high. This is really just a fallback thing above idle, so don't want it to be too high. So, okay, it's got, these are its min and max priorities. We want it if it's idle for a time for it to do nothing. So, okay, we want priority build rate. This is going to be how fast our priority increases. So we wanted to say maybe be idle for 10 seconds. So if it was idle for 10 seconds, then we want it to be able to activate. So I think this is something where a build rate of maybe 1 would do that. And that means we need to keep track of our current priority, which I am using a float here for this, just because I'm going to be incrementing this at a fairly slow sort of rate. So this is going to be a mathf. I'll do a floor to int of that current priority. Now, if we take a look at with our goals, we do have the option for being able to tick them. So that is where I would update the priority here for wander. So we would have on-tick goal. So we won't run the base version, but we would ask the agent, is it moving? If it's moving, current priority goes to 0. Otherwise, the current priority we add our build rate by time.delta time. And actually, this is something where rather than we'd have a build rate, which we might make that build rate, that's pretty good, actually. I think then we would have a priority decay rate. So if we're moving, then we decrease the priority. Priority decay rate times by time.delta time. So we'll decay at a much slower rate. And then what I would do as a final thing, because okay, this is going to have the priority move, shift and move up and down, but as soon as it becomes above the idle goal, it would immediately activate, then it would decay and go below that. So what I would want to do in that case is when it becomes active, which we have on goal activated, public override void on goal activated. So in this case, current priority is equal to max. So when it becomes active, it forces the priority up quite high. And then the priority can drop down afterwards. So then I might make that decay rate much lower and maybe boost that max priority up a bit. So priority is going to increase, it's going to activate. At that point where it activates, it's then going to immediately bump that priority up even higher. And then that means then it can decay a bit after that. And it's always able to run, so we can leave it as that. And then our agent needs to be able to tell us if we are moving. So what we can have is a public pool is moving, and we should be able to find out whether we are actually moving or not. It is stopped. That's probably going to work. We'll find out. Cool. So keeping track of if it's moving. So now we've got two goals sort of set up there that are keying off different things. So that's, I think, enough for us to be able to work out, and see the general behavior of his stuff activating. So I'm going to set up start here, which this is going to talk to our UI and that a little bit in a moment. So we're going to do update. Update is going to tick our goals, just so that if there's any updating that needs to be happening there with it. And then what we will be doing is, because I set up some debug UI system here, so we are going to have GOAP UI, debug UI, which this I will retrieve down here because it's on another thing and I need to actually find it. So it's going to find the GOAP UI. And what it will be doing is in update, it's going to say, hey, update the goal. Here's the goal. We're going to grab our name. So in this case, we will grab our type. And we can then grab the name for that type. And then we grab our status, which at the moment is just going to be blank. And then we can grab the priority. Should just mean we have our display actually showing the priorities there. So this is what we want to test out. So the way this ends up working is on our enemy character, and this is why I particularly like the GOAP setup, we just drag our different goals on here. So goal, chase, idle, and wander. So we just have those different goals on there, and then we should see our different UI appear. So we can see we've got our wander and idle goals, so we can see the priorities there. And so the idle is at its base level, wander is there and stopped. Now, if we take a look at how we're getting the one from the agent, so that may not be indicating back correctly to us. So this is something where we would want to go and check, okay, well, what are we getting for, is it moving? It's likely that we might need to actually check the velocity of it, which is fine. If we need to check the velocity, we can easily check the velocity. We'll just see what we've got appearing out of this. So it's saying that it is currently moving. So there is the is stop there going through the nav mesh agent, not the ideal, but we can check the velocity. So if the magnitude of that is greater than a very small value, then we'll say that it's moving. So let's test with this. And so it'll be running. So we can see it's saying it's not moving, and we can see the wander goals priority is ticking up, and it'll hit a point where when we don't have the activation logic in at the moment, but once we did have the activation logic in, we'd see that priority jump up. So that's good. We've got the priorities happening for those two ones. We also need to have the priority then happening for the chase goal. So let's get our chase goal set up. So chase goal, again, we inherit from goal base. I'm going to bring a few of these different ones over from the wander goal, because there's going to be a few different ones, because these are going to be a little bit more complicated. So tick goal, we likely will need to do stuff in, and potentially in activated, possibly even in deactivated. Void, on goal, deactivate. I'm just going to rename that so it's consistent. So we need to get a priority for this. So if we think the chase goal is actually not always going to be able to run. So we have to have something that we can chase. So the setup with the chase goal is going to be one where, okay, do we have something that we have fully detected, or we've detected enough, and then which of those are we going to actually chase? So it has to do a little bit more decision making here in terms of, well, which target do I choose to chase? Now in this case, once it picks a target, we'll have it continue to pursue that one, but this is where you could have it do switching of targets, things like that. You could also have a specific goal that's about selecting targets. There's different ways we could approach that. So when I tick the goal, well, firstly, for can I run, I need to talk to the sensors And now we don't have an interface at the moment for this in the senses of being able to essentially get back, okay, give me the tracked targets. We don't have an interface for that. So I'm going to have a setup here where I want this to be able to give me back a list of tracked targets. So active targets. And what that will do is that will map to dictionary values. So that one is because this track target needs to be public. All right, so we've got this. Now that is going to be complaining because it's trying to convert it from that. So typically we could potentially, I won't use, in some cases you could do something like using link or that for this. I'm not going to do that. What I'm going to do to make it a little bit cleaner is I'm just going to have it that it gives me back the entire set of targets. Just means I'm not doing as much sort of overhead there with transforming the data. So, well, firstly, if sensors active targets, that's null or empty, then we're going to do, we can't run. So that's a key thing there. We cannot run in that case. And I will also, not that we strictly need the priority to be being calculated for that, but if there's nothing, then there is no chance of this goal running. So no target. Okay, so with our sensor setup, we have this value, the level of detection from 0 to 1 to 2. 0 to 1 is activated by hearing sounds, and 1 to 2 is once we've heard stuff for a sustained time period or if we can see things. So I really only want to be reacting in that 1 to 2 range. So we're going to have min awareness to chase. So I want the awareness of something to be at least 1.5 before we start chasing it. Then we'll have awareness to stop chase, which will be 1. So soon if the player gets far enough away, our awareness drops below 1, we want to stop chasing them. So, okay, well, can run. Let's check if we've got anything that has where our awareness of it is over that threshold. So, for int target, actually we might use a for each for this. Obviously potential performance impacts there, but for getting it up and running, for each is going to be quicker, and then we can come along and optimize later. If it's commonly retrieved stuff, then we would potentially cache it just in the sensor system itself. So in sensors, active targets values. So if candidate awareness is greater than min awareness to chase. So we've got something that we have more of an awareness of, then we can return true. Otherwise, false. So check if we have anything we are aware of. So that's good. So we're going to do a similar bit of logic here. Now, we potentially could do some combination of the two there, but I think it's good to just have separate locks there. I find it's often useful to split out the concepts of priority and whether or not something can run. So in this case, whether or not something can run is going to, or the priority to run is going to be tied into this. So if something is above in this case, there's a bit of a dependency here of, okay, well, do we have something, the priority is going to depend on if we have something currently to chase, because that's a thing where we might have a current target. So detectable target, current target. So we want to check against that first. So if we have a current target, if our current target is not equal to null, then we want to check what our awareness is for that. So we're going to go through and check all of these targets. And firstly, what we want to check is f candidate dot detectable is equal to our current target. Then whether or not our priority here is going to be based upon, is it still above that threshold? So what we could say is if the candidate's awareness is less than our awareness to stop chase, then our priority is 0. Otherwise, we'll have one here, int chase priority. We might say we want it to be fairly high, so 60. So in this case, we return the chase priority. So this is handling if we've got a current target. Check if the current target is still sensed, would be the better term here. If it's still sensed. If it is not still sensed, so if we get to the end of this loop, then that means current target becomes null, and we have to pick another target. So clear our current target. So this is handling the case of, do we still have our current target? So this is, we've still got it. This is, we've lost our current target. So then acquire a new target if possible. So now we're checking this case of, is any of them above our threshold to chase? If they are, then we return our chase priority and we populate our current target. Candidate dot detectable. Found a target to acquire. So that means then when we deactivate the goal, that we probably don't need to, but I think good just to update the priority at that point. Now this, we are doing a fairly straightforward check here. We could also move this so we have our current priority that we do this calculation, because we are calculating priority a couple of times. This would be good as something to put into our ticking of the goal. So what we would be doing is, a way that I would set up this is, okay, well, current priority, I'm going to force it to 0. So that means if we get to here, we just exit. If we get to here, current priority is updated. This is just minimizing the amount of times we need to run our code here, because it isn't going to be super cheap code. So if we can minimize the amount of times we're needing to run it, then that's better. And we're just using early out, so doing returns like this are a way of just earlying out of the code, really handy. And it means then our priority calculation goes to be very simple. So, okay, well, we've got set up with our chase goal that's tying into our awareness system. So that means we also need to make sure that our player character is providing the information the awareness system needs. So that means that our player character, if we take a look at them, then we've got the detectable target on that, which is good. We also need to make sure that we have our different managers, which we've got our detectable target and our hearing manager set up, which is great. And so that is looking pretty good for us being able to run this. And we can check and make sure that our enemy character, its vision sensor, so its detection mask, it's just looking at default. We've got our chase and wander and other goals. Excellent. So let's run this up and see what we're seeing for priorities. So we've got our goal, wander, idle, and chase. So you can see our wander goals priority is building up. So our AI is able to see us, and so you can see the chase priority there has gone up. Chase priority is still at the maximum, but we should expect as its awareness of us drops down, that chase priority will end up going down to 0. So now we've got our different goals, changing in priority as they do particular things, which is great. Now we want to set up our actions, because our goals, we've got them up and running, but we want to be able to set up our actions associated with this. So, okay, because our actions in most cases are going to be super simple. Again, that's one of the things I really like about GOAP, is that our setup for the things is actually quite minimal. So actions, we again are going to have an action base, and we're going to have ones for the different behaviors. So idle, chase, and wander. So we'll get all of these set up, and we don't have that min priority, so we can get rid of that. And I'm going to change this to wander priority, seeing as we don't have min and max anymore, just so I got some clearer names with things. So, okay, that's good. We've got that sort of set up. Our actions are going to be quite similar in many ways to our goals in terms of a lot of the setup there. Now I will just set up the inheritance setup here. So this is our chase one. So chase and wander are going to be quite similar. Idle is going to be very, very simple. The idle one is going to quite literally do nothing, because that's all it's doing. Now we could obviously we could have it be playing random audio, we could have it be playing random animations, things like that. In this case, we are going to have it do nothing. So, all right. So similar to goals, actions don't have a priority, but actions do have a cost. That is something that all actions will actually have. So they will have a function, public virtual, and I'll allow this to be a float, I think. Cost. This way, if we have multiple actions that could satisfy the same goal, then those actions are we can just choose between which one's going to be most appropriate. Now we need a way of being able to say what goal does it actually satisfy. So what I'm going to do with this is we're going to return a type. And this will indicate what it can actually satisfy. So this will be public virtual system.type. And we could have a particular action able to satisfy multiple ones. So I might support that. It's not necessarily a common use case, but I think good to factor that in, that we can sort of support multiple ones. So get supported, actually that's just called, get supported guys. Which the default version will just return null. So, okay, that's pretty good. We can get the supported goals, we can get the cost. Similar to with the action, the goals, sorry, these will have the ability to be woken up. So virtual void on activated. They can also be turned off. So on deactivated, so if an action was running and then now is not, then it will get turned off. And then finally, virtual void on tick. Now, I think it'll be useful for actions to, similar with the goals, they're going to want stuff like the sensors and that information. So I'm going to make it that we have that. Won't have the debug UI. I am going to give them access to the goal. So the linked goal, which could change, which is why I want to have it set up like that. So that looks pretty good. I specifically won't in update actually do any ticking. That's going to be driven external to this. So, okay, we've got the goal. We have different bits of information here. That looks pretty good. So let's set up these for the idle action, because that's going to be one of the really simple ones. So this needs to override, and similar with this. So what I would do is, because I don't want to calculate this every single time, ordered goals equals new list of goals, and that we can then initialize that with the particular idle goal. Which actually I could make that. That doesn't need to be a list. That can just be an array. So that can be new system.type. And then how we end up using that is we would put here type of goal idle. And then this just returns that. Which does mean I need to refactor this a little bit so that it like that, which is fine. Just makes it a little bit cleaner. So, okay, got our supported goals. Cost, well, idle is pretty darn cheap. I think 0 is perfectly fine as a cost for it, and there's nothing else it needs to do. That's it for our idle action. So this is what I like about GOAP. Our implementations tend to be quite short. So that looks good for idle. Let's set up for our wander action. So similar, this ends up being goal wander. Again, it's going to be really cheap. Now, wander needs to do a little bit more. So wander is one where we have to actually be doing stuff like our activated, deactivated, and our tick. So these, because wander needs to pick a location. So, okay, it's got to pick a location, head to that location. Once we're there, pick a new one. So activated is where it will pick a location. Tick is then where it needs to go and ask the agent, well, are you at the destination? So at destination, if it is, then we just run our onActivated again. Arrived at destination. So again, we don't do the logic for determining are we at that destination. We let the agent handle that. So it's about fairly strictly partitioning the responsibilities here for whether we're actually at the particular locations or not. So, okay, this we're checking for where we're at. So what we could be doing here is public bool at destination. And this is something where there's a few different ways we could be doing this, because we can see if the path's not pending and we've set that and it's actually reached the destination. So I'm going to set up a bool here, reached destination, which is going to be false. And when I reach it, I will set that to true. And then when I set a new path, then I will actually reset this. So if we cancel the command, or if we set the destination, then we reset those to false. So it gives us something where we can easily check and see, have we reached that destination? So that's good. That'll run and move to that. Well, then activated needs to pick a location. So let's just initially, so location, because how this would work is it would go, hey agent, move to, and then that location. So very little logic that it needs. Key thing is we just need to pick a location nearby. So again, that's something where we don't want necessarily the behavior to have to know the intricacies of how the path data is sort of set up. So what I would be doing is potentially something like, okay, agent dot find location in range, or pick location in range. Location in range, and I give it a search range. So this is something where the wander goal, we would have a search range. Let's pick something within 10. So what that means is then our agent can do the logic for working out, okay, well, where do I actually head to? Because it has access to the path data. So what we would do is public vector3 float range. And then if we have a look at what sort of stuff we've got, because we can go through the actual agent, and we can see in terms of with the agent that we've got stuff like sampling the path position, stuff like of that. We can also go just direct to the nav mesh itself. So we can see we can do nav mesh dot, and then we can search for particular stuff. So the main thing we generally use there is something like a sample position. So what we could do is a sample position, and we have a source position that we need to provide it. And we can see sort of the setup here. So what I could do is we sample a position, the location we pick here. So I could search location, do something where vector3 search location. That might start at our current transform position, and then what I could do is search location equals random.range minus range times by vector3 dot forward. So we're doing a little bit of an offset in that direction, and also right. So we find the nearest location within that range, and then we search to find a valid point there, and then what we would do is we would return hit result dot position. Otherwise, what we would do is just pick return our search location. Actually, we'd return our current position. Yeah, we could do more sophisticated stuff of grabbing more info of the actual contents around us and trying to sample that, but I think this will be sufficient for it to pick a location. So When it gets activated, so when this action starts to run, it picks a location, tells it to move there. And the advantage with that is if this happens to be the same thing, this will very rapidly go to say it's reached the destination, which will then mean it'll pick a new location. So then as soon as we're at the destination, it just runs onActivated again to pick a new location. And that's it for Wander. Again, very, very simple in terms of the logic. Now, the final one we will set up is for chasing. So if we have a look at the chase one, now again, we're going to keep the cost to 0. Again, with the goals, it's going to just be this. Well, in this case, it's actually a little bit even easier because we do want to move to a location, but we want to move towards our target. And we could do particular stuff when we're at that destination, but largely we're actually going to just be continually moving towards that target. So what that means is we actually need to have a little bit of communication happening here between the goal and our actual sort of setup for the action. Because the action needs to know, well, what's the target that I'm trying to head towards. So what I could do is on the goal, I could give this a function, or I could set up a property where we have the move location or move target. Because again, the action doesn't need all of the information, so it could just be if current target is not equal to null, then what we head towards is current target transform, actually current target, and we have the position already in there, I think. No, we don't actually. I thought detectable target did have that information. Oh, transform position. Otherwise, we're going to say we just are heading towards our position. So this is something that I can retrieve in the action, because the action knows the particular goal. So I can set up here goal chase goal. Now when I get activated, well, chase goal, I know linked goal will be populated. So I get the linked goal, and from the linked goal, I could retrieve that as a goal chase. I can just cast it to it, because then I move towards chase goal dot move target. And then down here, I also move towards that. It's just going to continually head towards it. So we cache the chase goal, and then we're moving towards the target. When we get deactivated, we can null that out. Okay, so we've got our actions, and there's not too much to them, as we saw. Cost is something we could implement. There's some general common stuff we have to set up for them, but the actual logic, especially because we've done that partitioning where we've got our movement navigation system separated from the rest of our logic, keeps it all nicely partitioned. So to attach these actions, again, and this is what I like about this sort of structure, what we do is we just drag these actions onto it. So, okay, well, now it has the ability to satisfy its chase goal, its idle goal, and its wander goal. Really straightforward for being able to mix and match and configure ones. So it allows it to be really nice and quick and easy for getting it set up. So, okay, now we need the planner. So the actual GOAP planner. This is the one that needs to go through and determine what stuff is actually running. So this is the one that does a lot of the heavy lifting. So what it's going to be doing is it needs to firstly find out, well, what are the set of goals I've got? What are the set of actions that I've got? So that's the first thing it's going to be doing. So we have goal, base, or goals. Actually, I can just call that goals. Goal action, or sorry, action base. Actions. So we just retrieve these here, and I can retrieve these in awake. I'm not going to be doing any communication with them at that point, but I can retrieve them here. So I can say get components and goal base, because we've got inheritance set up, that will retrieve all of them. So actions, get components, action base. Perfect. So start, it's not going to be anything we need to do in that. But update, there will be. So first thing we want to do is with the goals, we want to just tick them. Because ticking a goal doesn't mean that that goal is actually active and running. It's just giving it a chance to update any priorities, things like of that. So for each goal in goals, and then what I would do is goal on tick goal. So just gives them a chance to do any priority logic, anything like that. Update all of the goals. Now we need to start working out which one should be running. We're going to need to know what one's already active. So active goal, and we'll also have an active action, active action. All right, so let's go through and work out what is our best goal. So goal, base, best goal. And then, so the first step we do is we're trying to find the best combination, because it's not just the best goal, it's the best goal and associated action pair, because if we can't actually complete that goal, it's not really any use to us. So action base, best action. So these, I'm just going to explicitly make them null. Find the highest priority goal that can be activated. All right, so for each goals, and we could actually do our ticking here. So first tick the goal, tick the goal, goal on tick. So, all right, we've done that. So we've ticked it. Can it run? If the goal is not able to run, then we skip it. If it can't run, then it's immediately out of the running as a potential option. Is it a better priority? So if either the best goal is equal to null, or if this goal's priority is greater than our best goal's priority. So if it's a better priority, then it might be better. If it's not better, if it's not, then we actually can skip it. So in this case, is it a worse? So what I would do is, because this will run if we don't have a best goal, it's automatically the best potential one, or if its priority is better, then it's improved. If we invert that, then we can just do continue. I prefer doing this sort of structure where I avoid the things like for loops and that getting too deep. I find is a good approach. So now we need to check if we've got an action that can run it. So we loop through all of the actions for each action in actions. Well, first thing is, can this action actually satisfy this particular one? So the way we can check that is action, supported goals, if that, and we need to check if it contains the particular one. So we can do, now it's giving us back a array, And that's why I had it as a list, so that we could do contains on it. So I am going to change this back to being this. It'll means a slightly messier setup for initializing these particular things, but it means that we have one that we can easily just do a contains on, which is definitely a better option there. Override list, got our idle one. So what that means is we can still largely keep the way that we're initializing it. Just means it's a little bit more messy and convoluted than what it would have been otherwise. Knew there was a reason that I was going for using lists to begin with. New list system.type. So we can initialize stuff like that. It is a much more convoluted setup that we've got there for it, but it will mean that our downstream code is simpler, and it's not something where we're going to notice the performance impact hit there of that. Because that just means we can now do a contains, and what we can do is we can do goal get type. So we just check the type of the goal, make sure that it contains it, and again, following my approach of flipping the logic, if it doesn't contain it, then we do continue. Now I'm going to say here a candidate action, because actions have a cost. So find the best cost action, because possibly I could find no actions that are suitable, so I don't want to necessarily start overriding this because there might be better goals, things like that. So I want to not override that until I am confident that I can. So down here, what we would be checking against is, okay, well, if this is a better cost action, so if either the candidate action is null, or if our action cost is less than our candidate action's cost. Candidate action get cost. If it is, then candidate action is equal to this. Found a suitable action. Just going to default that to null. So then here, did we find an action? If we did, so if candidate action is not equal to null, then and only then can we update the best goal and action. So we know we've found something that's suitable. Because then best goal is equal to this one, and best action is equal to our candidate one. So we've done our search, we've found the particular suitable ones. So then now we need to work out what's sort of happening here. So a lot of different scenarios. So one scenario is if no current goal. So if the current goal, or the active goal, so if active goal equal to null, well then that makes it easy. If the active goal is equal to null, then our active goal becomes goal. So our best one, our active action becomes our best action. We need to tell everything that it's been activated. We'll look at doing that in a moment, but that's if we've got no current goal. Otherwise, we've got a current goal. So we know we have a current goal, but it could be our best goal is the same. The active goal is equal to the best goal. So in this case, we've got no change in goal. Well, we could have a change in action. So if you might have found a lower cost action that can now achieve that particular goal. So if the active action is not equal to the best action change, then again, active action is equal to best one. Otherwise, we do very little, except what we would do is we would tell the active action to tick. Which that I can probably do further down. This I would do here if we have one. If we have an active action, then we tick it. So okay, the action's changed. Now, so that's if the active goal was null and we now have a goal, and best goal is not equal to null. So no current goal and we found one. Otherwise, if we've got no change in goal, check for a change in action. Otherwise, well, there is another scenario where, okay, our active goal could be different to the best goal. So we're changing to a different action. So if active goal, or we could be switching off the particular one. So if active goal is not equal to best goal, so new goal or no valid goal. This will only run if we previously had a goal though. So because if the active goal was null, then it will go into here. And actually we can remove that. So if we've got no current goal, it goes into there. If we've got no change in goal, or if we have a change in goal, then we can go and check and see, because what we might need to do here is we would need to turn off the previous goal. So active goal on goal deactivated, active action on deactivated, and then active goal equally best, and active action is equal to best action. So this will handle if we are switching things off. And then we're activating things. So now we'll start setting up the particular activation logic. So if active goal, then we'll tell the goal to activate. So there's a lot of little bits of setup here, but this is something that once we've got it up and running once, we don't need to do a lot of things with it. If active action, then we tell the action to activate. Unactivated, so that's good. Well, here we're changing action, so that means we would do active action on deactivated, and then we activate the one, and then active action on activated. So that's good. So we're switching which ones are present, and then our final setup here would be happening up in this one. So this one will enter if we don't currently have a goal. Now these could be null because it could have found nothing. So that's why we're doing some null checks here. But if it did find something, it's going to activate it. So first time something runs, it'll go through here, it'll get activated. If then afterwards, well, the best goal is still our active one, then we just check and see, has the action actually changed? If it has, then we need to do some switching there. Otherwise, we've got a change in goal. And we know at this point that our active goal can't be null. So we need to switch off the previous one. And then we switch over to new ones. And if they're present, then we link them up. So that's looking pretty good. Now, we want to add in a couple of little final bits where our goals know what thing is they're actually linked to. So in this case, action base linked action, is what I can do here is when it's got a linked action, it's active, or it's paused. Or actually, let's make that running or paused. So if it's got a linked action, which that linking of the action, we can make that be, there's a couple of ways we could do this. I would be typically inclined to make it that we populate this in onGoal activated. So we can set it here. And then down here, we can clear it. The action is null. This does mean we need to do a couple of updates to some of our ones like our chase goal, but these actually, in this case, we can delete it. So it makes it a very simple setup for a bunch of these. Wander needs a little bit more of a setup, but not much, because we can just do base, onGoal activated, linked action. So that's good. It means our GOAP planner is able to pass through these. So it means our goal knows whether it's got an action. Now we also needed the actions to know about the goals. Remember. So we need to also factor that in there. Just this, we need to put in action base and action. So our actions also get told. So in that on activated, we're going to make sure they have a goal base, linked goal, and we'll again do the similar logic we did where linked goal, just pass that through. Here we'll reset it. And then we just update any of the actions that need it. Not too many of them are making much use of it, which is fine. Base on activated, pass through the goal. Same in chase, where we can just pass that over. So as I said, it is a bunch of initial sort of setup stuff we're having to do. It does add in a bit of overhead with doing that sort of setup for it. But once we've got it up and running, it's pretty quick for being able to then add in extra stuff. So this links over to our active goal. And that should do it. This can find the goals, find the actions, can run through the logic there. So this just gets attached on, and this is a script that we don't tend to need to do much in the way of maintenance to. Most of our stuff then is we just drag in new goals and new actions. So what we want to do is run it, and what we're hoping to see is, so the idle goal is running, which is good. So I'm going to wait, and we see the wander goal switched over to running, and we can see, if we look at the position there for the character, they're moving. And I'm going to go find them so that they can become aware of me. Oh, where have they gone? Where did you run off to? There we go. So it's seen me and now it's chasing me. And so we can see that's the highest priority there. And if I manage to run away, hopefully far enough that I should be out of its awareness. And then it stopped chasing me and it's gone back into, you can see it's got chase goal is not properly reset. So that's something where we might not be properly deactivating. So we need to make sure when we're deactivating, we run the proper deactivation logic there. But we've got a AI setup that to add things to it, we don't need to change our GOAP planner script. We just change our wander, idle, chase ones, add in extra ones. So let's recap on the stuff here because there's a lot of bits we set up, but not all of it do we actually need. So let's focus on some key things. The planner, we don't need to be doing further maintenance with that. This is something that now that we've got it up and running, it's going to handle the logic for us. So it'll seamlessly switch between the goals. It'll tell goals when they become active and deactivated, and same that it'll handle if actions change. It tries to find the lowest cost action, and so if it, while it's running one goal, finds a better action, it can handle that. So let's look at our actual goals first. The goals, they ended up being quite a small amount of code. We saw, if we have a look, we'll have our base goal here, and we'll have our different ones over here. Idle goal, super simple. Fixed priority, always can run, just returns that. Chase goal was the most complicated one, and that was because it was calculating its priority dynamically, because it was looking to see, do I have targets that I can actually chase after and pursue? If I do, then okay, I'm going to have a high priority to activate it. So it had more overhead there in terms of how it was calculating the priority, how it was determining whether or not it could run. Wander was sort of a midway range, where Wander had a sliding priority based upon how long it had been doing nothing for. As soon as it was doing nothing, then it was going to tick up an increase in priority. And we have fairly simple setup in terms of functions that we need to support to then be able to have our goals calculate priority. So goals are about what do we want it to do. They don't perform any of the logic. Goals are only used to decide, do I want to do this thing? That's the key thing that the question they're answering is, do I want to do this particular thing? So, okay, that's what the goals are doing. Then we go over to the actions. So the goals determine whether or not we want to do something and how important it is to do. Actions do the thing. So actions need to say what goals they support and then can provide a cost. Higher cost is worse, so we want the cheapest possible action for a particular goal. And we can have multiple different actions that could facilitate the one goal. That allows it to flip and switch between different ones. So actions, if it's a case of something like the idle, super simple because it does nothing. We could have it be picking an animation, stuff like that to play, but it's going to be very minimal logic. Our wander goal is a next step up in terms of complexity, so it can pick a location to head to, and we'll head to that location. Once it's there, it will then go and pick another location. So again, fairly simple logic. We actually don't even need the deactivated there for it, so we can get rid of that. So very simple logic for it. Picks location, and part of that is because we partitioned that logic for being able to move to locations, to interact with the path data, the navigation mesh, is partitioned into a separate area that we typically call like the navigation system. So that means that this ends up being a lot simpler. Because this isn't concerned with how do I get there. Its job in the action is where do I want to go? And then what do I do once I get there? The navigation side handles how do we get there. And then the chase one didn't end up being much more complicated. Because for the chase one, it was still quite simple in terms of what it was doing. We're providing some key info in terms of where we get our move target, and we always move towards it, but that's it. And we just have to actually do very little logic with it. So this is what I like about GOAP. Really simple in terms of what you end up implementing within the actions. Something that pairs really nicely with this is often using state machines inside the actions. So you can have a bit of a state machine there for if you want to have more intricate logic happening. But the key thing is that we split up this idea of deciding how important it is to do something and what are we doing against how do we actually do it. That's the big advantage there with GOAP, and it gives you a really sort of powerful setup. And then what behaviors, what abilities a character has, we just drag them on. It's just down to what scripts we attach onto the character. So it makes it really powerful for working with that. So dive in and experiment with it and see the kinds of things that you can be creating there. And I hope you've really found this helpful. If you are looking for things like the code for the project, the full code is up there on GitHub. So grab that code, mess with it. It's done fairly modular, so you can bring it into your own projects. And if you found this helpful, do chuck in a like and a subscribe, really helps out. And if you're looking for other ways to help out, then I do have a Patreon, which I've put the link in the description below. But dive in, experiment, see the kinds of cool things you can create.